exponent. So if you have x to the negative 5, that's actually 1 over x to the 5th. If you have x to the negative 2, that's 1 over x squared. So whenever you see a negative, you can put it over 1 over x raised to the positive version of that number. All right, so the next rule that we have is when you take something raised to an exponent and then raise it to another exponent, right? So x to the a raised to the b. So when you take something raised to an exponent and raise it to another exponent, what you end up doing is you multiply the exponents. You multiply the exponent. So this would be x raised to the a times b power. X raised to the a times b power. All right, so the third rule that we have has to do with, it's kind of just a notation, really. So if we have x, and if I just write this, you would think this is the square root of x, square root of x. And there's kind of like an invisible 2 here. You could think of there being a 2 here as the square roots. But more generally, we can put any number here. We can put any number here and say that if we write this, x, we're taking the nth root. We're taking the nth root, and we can write that as x to the 1 over n, as x to the 1 over n. So a common example you'd see is a square root. So if I take the square root of 4, the square root of 4, I could have written a 2 there. You typically don't see that, but you could have written a 2 there. This is the same as 4 to the 1/2 power, which is equal to 2, or negative 2, but typically you would just use the positive version. You could say all these things are equivalent. 2 equals 4 to the 1/2 power, which equals the square root of 2 as it's written over here. But you could also see that just written with the radical sign. So these are all the same thing. These are all the same thing. All right, the next rule is when we're dividing exponents. So if you have something raised to an exponent, say x to the a, and that's divided by x to the b. So let's say the same base, but different exponents. So all we're going to do here is when we divide the same base with different exponents, you can just subtract the exponents. It's going to be x to the a minus b. X to the a minus b. So whenever we have the same base, we can do that. If the base is not the same, you can't just use this neat little rule. But if the base is the same, you can do that. So x to the a over x to the b equals x to the a minus b. Second to last rule, I know this is a lot, but instead of dividing like this, we're going to be multiplying. So if we have x to the a times x to the b, some of these rules you might already know, but this one here, you can see in rule number 4, when we divide, we're going to subtract the exponents. So when you multiply, you're going to add the exponents, a plus b. All right, and then the last rule that we have here, and I kind of didn't notice this till later, they didn't teach this specifically in the video, but it is going to be useful. So if you have the product of something, so let's say x times y, and I'll even do another, let's say x times y times z. So you have a bunch of things being multiplied, and if those are raised to an exponent, you can, in a sense, distribute the exponent. Now, you can only do this when things are multiplied or divided like this. You can't do this when things are added or subtracted. But if you have, say, x times y times z, all raised to the a power, that's the same as x to the a times y to the a times z to the a. So we have a bunch of things multiplied and then raised to an exponent. You can raise all the individual pieces to an exponent. All right, so then what we're going to do here is take a look at all of these questions, and we'll go question by question, and I'll say what rule I'm going to use. I'll call them 1, 2, 3, 4, 5, and 6. Then we'll answer each of these questions. So the first one asks, which expressions are equivalent to the 4th root of d raised to the 3rd power? That's the 4th root of d raised to the 3rd power. So let's think about how we can rewrite this using the rules that we already kind of know. So one thing that sticks out to me, the first thing is rule number 3. So I have this little n thing here. So we're taking the 4th root. So basically what this means is instead of writing it like this, the 4th root of d, according to the rule, I can write it as d to the 1/4. To the 1/4. So these are the same thing, d to the 1/4. So now what I have is I have d to the 1/4 raised to the 3rd power. So see what I did here is the expression in parentheses, I wrote this as d to the 1/4, and now I'm raising that to the third power. So now what we can use is rule number 2. So when we multiply exponents, or when we take something raised to an exponent and raise that to another exponent, we're going to multiply the exponents. So this is going to be d raised to the 1/4 times 3. And I like to write that as 3 over 1. And this is going to give me d to the 3/4. D to the 3/4. So now what we're going to do, so I've kind of written this in a couple different ways. So this is d to the 3/4. You can also think of it as, d to the 1/4 raised to the third. It's all the same thing. The 4th root of d raised to the third. So now what we're going to do is go answer by answer and see which ones of these are the same, if any. So this one right here, it says d to the third, and we're taking the 4th root of that. So what's going to happen here is for the 4th root, this is going to be d to the third, and that 4th root is actually to the 1/4 power, right? That's rule number 3. That's actually the 1/4 power. So now, similar to the first example, right, you can multiply these exponents. 3 times 1/4 is 3/4. So this is d to the 3/4, and that is the same thing that we got before. So A will work. Be careful with these. It says choose all answers that apply. So there might be more than one correct answer. If we look at option B, this is saying d to the 4th raised to the 1/3 power, because we're taking the cube root. So when we multiply the exponents here, it's going to give us d to the 4/3, which is different than d to the 3/4. So the exponents are different. So this one's not going to be correct. And if I check here on C, so I'm taking d to the 1/4, and I'm raising that to the third power. So I'm going to multiply these exponents, just like rule number 2. And that's going to give me d to the 3/4, which is the same as option A, and that's the same as the original. So my answers here should be A and C. So let's take a sec here. A and C. All right, nice, got that correct. I'm going to do some erasing here. Let's see. All right, let's take a look at this one here. So it looks like what we have is, it says rewrite the expression in the form z to the n. So we want to have z as our base raised to some exponent n. Just going to figure out what that exponent is. So if you look at this expression, it looks a little wonky. And what I'm going to do is I'm going to simplify what's under the square root and then take the square root of it afterwards. So let's first focus on z divided by z to the 1/3. There's a couple ways to think of this. What I'm going to do is I'm going to use rule number 4, the rule for division. So when you have two things being divided by each other, notice the base is the same. These are both the z. And the one up top, you can think of it as being raised to the first power because it's z by itself. So all we're going to do here is subtract the exponents. So it's going to be z to the 1 minus 1/3. So it seems very tricky, but that's kind of straightforward. So what is 1 minus 1/3? Well, 1 is 3/3. So 3/3 minus 1/3 is 2/3. So I have z to the 2/3. But that's not the answer, because remember, this was all under a square root sign. So I take the square root of this. So what does that mean? So if I'm taking the square root of something, and it's kind of like the example 3, right? So if I have the square root, that's going to be the same as raising it to the 1/2 power. So here, instead of z, and I'll rewrite this, instead of z to the 2/3, I'm not taking the square root of that. Well, I am. I'm just going to rewrite it. I'm going to rewrite this as z to the 2/3, but I'm going to raise this to the 1/2 power. That's the same thing as taking the square root. So this is z to the 2/3 to the 1/2 power. And now I can look at rule number 2, and I can see that when I take something raised to an exponent and raise it to another exponent, I'm just going to multiply the exponents. So I'm going to get z to the 2/3 times 1/2. So across the top, I get 2. And across the bottom, 3 times 2 is 6. So it's going to give me z to the 1/3. I'm just simplifying 2/6 to 1/3. So hopefully 1/3 is our answer here. Let's check her out. Oh, give it another shot. Let's pause it. Okay, so I think what happened, actually, I hope what happened, I didn't write the letter Z. So I get a Z raised to the 1/3. That's the answer. The answer was not 1/3, it's Z raised to the 1/3. So there we go, got that one correct. Nice. All right, next question. All right, so in this example here, what we have is we have something, we're taking the 7th root of A, the 7th root of A. And we know from rule number 3 that if we take the 7th root of something, that's the same as raising it to the 1/7 power. So we'll say A to the 1/7 power. So this whole thing here is just A to the 1/7 power. And then we're squaring that. So according to rule number 2, when we have something raised to an exponent, raise it to another exponent, we will just multiply the exponents. So we're going to get A to the 2/7. So all we're going to do now is kind of look at these answer choices and see which one matches. It looks like A matches, A to the 2/7. So I think that one's correct. This is A to the 7/2. So the exponent is different. That's not going to work. This is A to the 7 over A squared. So that's going to be A to the 5th because we'll subtract those exponents. And that's not what we want. We want 2/7. And here, this kind of looks right. But remember, according to rule number 4, we're going to subtract these. So this is actually going to be A to the -5, which would be 1 over A to the 5th, which is not what we want. We want option A to the 2/7. All right, next question. Erase. Okay. Oh, this is fun. This one's easy. All right, it says which exponential expression is equivalent to the square root of k? Square root of k. Well, when we take the square root, you can imagine that invisible 2 there. What we're saying is this is the same as k raised to the 1/2 power. So the square root is the same as the 1/2 power. It's kind of just a definition. It's like an identity. So the square root of k, does that equal k squared? No. Is k to the 1/2, not to the 2. Is this equal to k to the 1/2? Well, let's see. The 1/2 is in the bottom of a fraction. So according to rule number 1, this is actually equal to k to the -1/2. Because all we would do is just put this as 1 over k to the +1/2. So no, this would be an exponent of -1/2. We need +1/2. Right here, we have 1 over k squared. This would just be k to the -2. Same concept as the previous option. And then this here is literally just writing k to the 1/2. This is kind of an identity, is that raising something to the 1/2 power is the same as taking the square root. So we'll say D is the correct answer there. The square root, that's the same as raising something to the 1/2 power. All right, and last one. So let's erase. All right, so this one says which expressions are equivalent to the 7th root of v to the 3rd, the 7th root of v to the 3rd. So if we have anything to the 7th root, that is raising it to the 1/7 power. So we had v to the 3rd, and we're now raising that to the 1/7 power. So that's kind of the third rule, is understanding how to work with the roots there, how to work with the radicals. So looking here, we have something raised to an exponent, raised to another exponent. So we're going to use rule number 2 and multiply the exponents. It's going to give us v to the 3/7. So we need to choose all answers that match. So for A, same concept here. You can see that the setup is the same thing I had here. V to the 3rd times, or sorry, v to the 3rd raised to the 1/7 power. So this will be v to the 3/7. So that will match. So A is correct, should be. Right here, we have the cube root of v raised to the 7th power. So the cube root of v is v to the 1/3. And that is being raised to the 7th power. And when we multiply these exponents, we're going to get v to the 7/3. That is different than v to the 3/7. So this will not work for us. And C is actually just writing the version that we had in the beginning. So that one's going to match v to the 3/7. We're looking for 3/7. So it looks like our answers will be A and C. Perfect. All right.